Hello friends, in this video we are going to discuss one of the problem related to DFT. So here we are going to solve the problem by appending 0. Okay, so we will see all those things while solving the problem. Okay, so this is the problem. Okay, calculate 8-point DFT of the following signal. This is the signal, right? This is the discrete time sequence x of n, right? So also calculate magnitude and phase of x of k. X of k is the DFT of x of n. It is a frequency domain signal. This is a discrete time signal, right? Okay, so here they have given only 4 points, right? So 0, 1, 2, 3, right? So here they have given only 4 points, but here they gave n value 8, capital N value 8. So we have to calculate 8-point DFT, but they have given x of n value, right? It is a 4 point, isn't it? So capital N is equal to 8 point L. Here we are denoting the sequence x of n sequence length as a L, right? So L is equal to 4. But so we need to calculate the x of k value for n point. So here we need to append zeros. So if we are appending zeros at the end of the sequence of x of n, it does not affect any meaning of the sequence. Okay, so we can append the zeros. Here we need to calculate how many zeros we have to append, right? So we know that n is greater than L. This is the condition. Based on this condition, we need to append the zeros. So we know that n is equal to capital N is equal to 8, right? Capital L is equal to this L. This is the x of n sequence length. Okay, so n is the need to calculate, right? 8-point DFT, right? 8 minus 4 is equal to 4, right? Here n is greater than L. I have written here as n minus L. That's all. Here we need to append 4 zeros at the end of sequence of x of n. Okay. See here, I have appended 4 zeros, right, at the end of x of n sequence. Now we know that the equation of DFT, right? X of k is equal to summation n is equal to 0 to n minus 1 x of n wn to the power of kn. So we know that n is a 8-point, k and n value varies between 0 to n minus 1, right? We know these things already, right? 0 to n minus 1, both k and n values varies between 0 to n minus 1. Okay, so here we know that the n value is 8, 8 minus 1 is equal to 7. So k values varies between 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7. We need to calculate x of k value, k values, x of k values for 0, 1, 2, 3, 4, 5, 6, 7. Okay, this is very big problem. Okay, so here I am not going to solve this problem, just I have given basic ideas, but I will solve the problem for 4 point. Okay, I will solve the problem for 4 point. Just follow the same procedure to calculate for 8 point. Okay, here this is, I have taken here, this is the small sequence x of n is equal to 1 comma 1, so 0 1, right? So the capital L is equal to 2, right? So here I need to calculate x of k value for n is equal to 4. Endpoint DFT is 4, right? It is very easy to discuss. Okay, that problem is very time consumption. That's why I switched over this problem. I switched to this problem. Okay, n is n greater than L, n minus L. 4 minus 2 is equal to 2. I have to append two zeros at the end of sequence of x of n. Okay, so thereafter we know that just we have to calculate the x of 0, 1, 2, 3. That's all. We need to calculate the x of k value for 0, 1, 2, 3. Okay. So here, as I said before in the previous video, so we can also, instead of applying direct computation method, or instead of applying the values for the direct equation, for the equation, we can also possible to calculate DFT using a matrix method. That is very easy. Personally, I will I will tell you to solve the problem using matrix method. Okay, so don't but if they in your exam, if they are asking direct computation method, you have to use equations to solve the problem. If they are not asking, then you can use matrix method to solve the DFT. It is very easy. It is a time, it will take very less time when compared to the direct computation method. Okay, please use this method to solve the problem. Okay, so here this is capital X of k, right? So k value varies between 0 to 3, because here we have to calculate for endpoint DFT is 4. So 0 k values varies between 0 to n minus 1, right? 0 to n minus 1. So x of 0, x of 1, x of 2, x of 3, right? This is a twiddle factor. The main thing is we need to calculate twiddle factor. It is very difficult if you are if you are calculating the DFT using direct computation method. So by in the matrix method, so we can easily calculate the twiddle factors using a periodicity property. Okay, so we will see what is the periodicity. You have already studied that periodicity property. So just we are applying that property, we will solve the problem very easily. Okay, so see here, so this is k, this is n, right? This is row, this is column. Okay, so now we know that w subscript capital N superscript k n, right? So n is, we know that 4. This is common for all the twiddle factors. Only it changes in the subscript, right? Based on the values of row and column, right? So k, this is k, this is n. Okay, this is n, this is k. So in the subscript kn, 0 to 0, we have to multiply these two numbers. 0 multiplied with 0 means 0. So for if we are multiplying 0 with any number, it is 0 only. This is first one is very easy. Second one, 1 into 0, 0, 1 into 1, 1, 2 ones are 2, 3 ones are 3. Similarly, 2 into 0, 0, 2 ones are 2, 2 twos are 4, 2 threes are 6. Similarly, you have to frame this twiddle factor. So, 0, 1, 2, 3, because n is equal to 4 point. K varies from 0 to 3. N is also varies from 0 to 3. If it is 8 means, so k value varies between 0 to 7. Similarly, the n values varies between 0 to 7 for n 8 point DFT. Here, just we need to calculate for 4 point DFT. So that's why it is limited to only 0 to 3, right? So here we have to multiply this matrix, twiddle factor matrix, with the 8 point discrete time sequence, that is x of n. Here the n value is also varies between 0 to 3. Okay. Now first the main thing is we have to find out the twiddle factor values. Okay. So first we have to find out the first 4 twiddle factors. Then for other twiddle factors are very to calculate is to calculate based by using these 4 twiddle factors. By using a periodicity property, we can easily calculate other twiddle factors. Okay, so first we need to calculate these first four twiddle factors. See, we know that e to the power of, w subscript 4 to the power of 0 is equal to 1, right? So what is the equation to calculate twiddle factor? E to the power of minus j, right? 2 pi, right? 2 pi divided by 4. Here kn is, here is 0, right? Is equal to 0, right? So e to the power of minus j theta. This is, we can take this one as a theta. Okay. So cos theta minus j sin theta, right? So here it is 0 is multiplied with this value. So we will get cos 0, right, minus j sin 0, right? So cos 0 value is 1. Sin 0 value is 0. So that's why I have written here the W4 to the power of 0 is 1. Similarly, we need to calculate other three twiddle factors. So we have to follow above the above procedure to find out the twiddle factors of 1, 2, 3, right? So we will get, for W4 to the power of 1, we will get, what is the value? Minus j. W4 to the power of 2, minus 1. W4 to the power of 3, plus j, right? So first we have calculated first four twiddle factors. For the remaining twiddle factors based on the periodicity property, what is? So it will rotate. Okay. So W4 to the power of 4. So we have written W4 to the power of 0. 0, 1, 2, 3. The next one is 4. It will rotate again, right? 4, 5, 6, 7, right? W4 to the power of 4 value is 1. W4 to the power of 5 value is minus j, right? Just you have to substitute these twiddle factors in this matrix. Okay. So after substituting those values, so it looks like this. Okay. It looks like this. Okay. It looks like this. This is x of n value, right? So it is given in the problem, right? See here, 1 comma 1 comma 0 comma 0. It is a 0 padding, right? This is 0 padding. After padding the zeros at the end of x of n sequence, we will get this sequence. Okay. So we have to use this sequence. Okay. So thereafter, okay, just we need to multiply these two matrix. Okay. So you know already we have to how to multiply two matrix, right? This is row into column matrix, right? It is a one column, four rows, right? This is one column, four rows. Okay. This is a 4 cross 4 matrix. You know very well all those things. This is a 4 cross 4 matrix. This is a 1 cross 4 matrix. So just you need to multiply this row with this column. So if you are multiplying means 1 into 1 plus 1, right? 1 into 1, 1 plus, right? So again 1 into 1, right? Again you will get 1. So if you are multiplying this 1 into 0, 0. If you are multiplying 1 into 0, 0, right? Plus 0, plus 0, right? So we will get, if you are adding these numbers, we will get 2. Okay. So this is our 2. Similarly, you have to compute other 3 rows. So finally, you will get this answer, right? This is the x of k answer. It is in complex number. Okay. This is in complex number. We will get 4 rows, 1 column, right? 4 rows, 1 column. Right, here also this is row into column is 4 into 1, right? 4 into 1, sorry, this is 4 into 1, 4 rows, 1 column, row into column, right? So we'll get this answer, it is in complex number. So here in the problem they have given, we need to calculate magnitude and phase. So you have to convert this rectangular number to polar numbers using a calculator. I have already taught this one in our previous video. Just check it out there, how to find out the polar numbers, okay, using calculator. So this is in degree format. So we can also represent this number, this polar number in the radian. This is in degree, this is in radian. Okay. Um, so we will solve another problem. This is very interesting. Okay. So in your exam, they won't give direct question. So in some of the examiners, they can also ask the questions in different way, in the complex way also. Okay, it will be useful. Okay, while writing your gate exams and all. Okay, I am enjoying by while solving these problems. Okay, so we won't think like this. Okay, so while seeing these such type of problems, then only we come to know. So okay, we can the problems can also be asked like that. Okay, so the first 5 point of the 8-point DFT x of k of a real valued sequence are, right? So they have given, so out of 8 point they have given only first 5 points. Okay, x of 0, they have given DFT point, right? Just make sure while reading the problem you have to read carefully. Okay, I am telling again and again. Okay, please ensure, so while writing the problems in your answer sheets, whether you are writing a correct values or not, right? Whether you are understanding the problems or not, make sure. Okay, so because this is not a simple problem, just addition or subtraction, it is very big problem. Once if you are completing that problem, so again if you want to solve the problem, it will takes again 15 to 20 minutes. Okay, please don't waste your time doing like this while writing in your answer sheet. Be careful. Okay, so x of 0, so they have given x of k values. Okay, x of 0, this is x of 1, x of 2, x of 3, x of 4. So here you have to find out the remaining 3 points. They have given x of k value 5 points. You have to find out remaining 3 points because the end point is 8. Again, they have also asked to find out the x of n value. It is very interesting, right? So here they have asked only the one value, x of 0. It is very interesting problem, right? So we need to calculate remaining 3 points. So out of 5 points, again we have to calculate the x of n value, especially x of 0. So we will see how to calculate, how to solve this problem. Okay, so first you have to note down. Okay, first you have to note down what they have given, right? So they have given 5 points, right? So you have to calculate the remaining 3 points such as x of 5, x of 6 and x of 7. Here we can solve this problem very easily using a symmetric property. So why we have to study that properties? So in order to reduce the complexity of problem, so in order to solve the problem, so we are these properties will be very useful. Periodicity properties, symmetric properties. Okay, so these properties are very useful. Okay, so what is that property? Symmetric property. This is the symmetric property. X of k is equal to, what is this? It indicates stammer, complex conjugate, right? You know what is that complex conjugate, right? If we are getting the complex number, for example, x of minus jy. So you have to write, if it is complex means, you have to write x of plus jy. So whenever we have this symbol, j symbol, right? So in such on the time, okay, so you have to change the sign of this. Okay, you have to change the sign of this variable. So when once if we are getting this star mark, it indicates complex conjugate, right? X of k is equal to x star of n minus k. So we will see, we will look into the problem, okay? So see here, x of n minus k is equal to x star of k. N is 8 point. They have given in the problem, right? So this is k value, okay? K value is 3 because why I have written here 3b, because so we need to calculate x of 5. So if we are minusing with 3, right? This is n point DFT. I mean n is equal to 8. So if you are minusing with 3, then only you will get x of 5, right? So x star of 3. So again 8 minus 2 means I will get 6. 8 minus 1 means I will get 7. X of 7, right? X star of 3, x star of 2, x star of 1. We have all, they have given these values, they have already given in the problem. 1, 2, 3, right? So see here, 1, 2, sorry, this is 2, this is 3, right? So see here how the complex conjugate plays here. See here, so x star of 3, 0 point, see here, x 3 is here. So they have given 0 0.125 minus j 0 0.518. So here we have to change this sign into plus. So 0 0.125 plus j 0 0.518. Here 0 does not affect. So x star of 1. So again they have given in the problem 0 point, see here. So 0 0.125 minus j. So here just we have to change this sign, right? So we have easily determined by using the symmetric property other three DFT values, that is x of 5, x of 6, x of 7. The last one is we need to find out x of 0. So here it is a inverse discrete IDFT equation. So these equation you have to memorize. Okay, please note down all the equations in the small notebook daily, on the daily basis. Just memorize all the equation. We can't understand the equation, okay? We can understand one or two equation, we can't understand all the three, then it is a research, then we it won't complete, okay? Just memorize all the equation, make a small notes, okay? Note it down all the equations in the chapter wise, and memorize all the equations on the daily basis, okay? So this is a inverse discrete Fourier transform equation. X of n is equal to 1 by n, summation k is equal to 0 to n minus 1, x of k. Here just you have to note down, here we don't have minus j. So for IDFT it is a plus j, 2 pi by n into kn. Just you have to apply n value 0. So just we have to estimate the value of x of 0, right? That's why I have to put instead of just we have to find out the value x of 0 values, right? 1 by 8 summation k is equal to 0 to 7. N value is 8. 8 minus 1 is 7, right? K is varies between 0 to capital N minus 1. X of k, why I have written here is 1 means because the n value is 0. So if you are multiplying with the k value with k with 0, we will get 0 only, right? So already we have I have explained in detail how to find out this, right? Exponential function, right? We'll get 1, okay? This is 1. After that just we have to substitute, so x of 0 plus x of 1 plus x of 2, x of 3 up to x of 7, okay? Up to x of 7 we have already determined all these values, it is there in this problem, right? So just you have to substitute the given values and the determined values. After substituting you have to add these values, okay? You have to add all these values, you will get 0 0.745. Then if you are simplifying this value you will get 0 0.093125, right? So DSP is very fun, okay? Just you have to understand the problem, how to solve the problem, okay? I think you will understand this problem. Thank you very much. Happy learning.